Hello, this video is on section 10.3, which is titled Operations with Radical Expressions, and the learning targets are 1, to simplify sums and differences of radical expressions, and then the second one is to simplify products and quotients of radical expressions. So just as a little bit of review, looking at like terms and unlike terms, similar to what you've learned in AG1 and AG2, when combining like terms, you look at the variable is what you did. Like this example down here, 5x plus 2x, you can combine them because they have the same variable, and you just add the 5 and 2 together while keeping the term to get 7x. Well, the exact same concept works for radicals. So if you look at two terms that are being added with the exact same radical, you can add them just like you normally would with the variable, but instead you keep the radical exactly the way it is. So that's why up here I wrote like radicals. You combine the terms that have the same radicands, or the same number underneath the radical, and then unlike are any ones that have different radicals. So it's pretty self-explanatory or easy if you have like radicals, but if you have different radicals is where it gets a little bit more complicated. If you're adding or subtracting unlike radicals or different radicands, then you have to simplify one of them or both of them first until you can get a like radical between the two. So this is where we need to review back to our last section where we were finding perfect square factors of both of them. The square root of 3 cannot be simplified any more than it already is, but the 12 can be. And the square root of 12 simplifies to the square root of 4 times the square root of 3. Then the square root of 4 we can take because that's a perfect square, and that gives us 2 square roots of 3. So now we can add them together because we have like radicands, or like terms with the radicals. We have 1 square root of 3 plus 2 square roots of 3. That means in total we're going to have 3 square roots of 3. And that is how you add those two terms up together. When you're multiplying them, you can multiply underneath, but there's a few different ways you can do it, like distributing and foiling. This is all from AG1 and AG2. And remember, FOIL means to multiply the first, the outer, inner, and then the last terms together. So let's say if you're trying to distribute the square root of 5 times 4 plus the square root of 7, what you would do to distribute them is to take the term on the outside of the parentheses and multiply it on both terms on the inside. So 5 times the square root of 4, or square root of 5 times 4, gives you 4 times the square root of 5. And then the square root of 5 times the square root of 7, you are allowed to multiply those together on the inside. And I don't think any perfect square factors will allow us to reduce this. I think the only factors are 135, 5, and 7. Yeah, those are the only ones. So this is as far as we can simplify it down to. Now, if this was something that we could perfect square, like 36, we would be able to reduce it. But in this case, it's not. And then the same thing happens with FOIL. Let's just take the same term underneath or in the parentheses right there, and then let's multiply it by 2 plus the square root of 3, and they're multiplying together. So when you multiply first, outer, inner, last, multiply 2 times 4, and then to multiply the outer ones together, 2 times the square root of 7, inner, square root of 3 times 4, and then last is the square root of 3 times the square root of 7. We'll go through some more examples in class, but that should be somewhat review for you guys. But the one thing that is going to be brand new for you is something that's called a conjugate. Now remember last time we were talking about rationalizing denominators that you had to multiply by the exact term underneath. We multiply by the conjugate in order to rationalize an example like this, to where it's a number plus a radical, or there's something else being added or subtracted within that denominator in order to simplify. And instead of just multiplying by the square root of 5 on both the top and the bottom, what we multiply is by the conjugate. And the conjugate is taking the exact term that's in the denominator and just changing the sum or subtraction sign. So looking through a few examples, the conjugate of the square root of 7 plus the square root of 3 is going to give us the square root of 7 minus the square root of 3. They're the exact same two terms, square root of 7 and square root of 3, but the conjugate is just the opposite plus and minus. The conjugate of the square root of 5 minus the square root of 7 is the square root of 5 plus the square root of 11. So that's all you do for the conjugate. And then when you apply it towards rationalizing a denominator, you multiply by the conjugate on the top and the bottom. So you take this term down here in the denominator, and its conjugate is 1 minus the square root of 5. So that is what we need to multiply on the top and the bottom. Now when you multiply by the conjugate, you create a distribution within the top, so 8 times 1 and 8 times the square root of negative 5. And then down here you create a FOIL, or multiplying two binomials. And when you multiply the two binomials together, what you're going to notice is that when you multiply the firsts, 1 times 1 will give you 1. Outer, 1 times the negative square root of 5 is the negative square root of 5. Inner, 1 times positive square root of 5 is positive square root of 5. And then last is square root of 5 times negative is negative square root of 25. What you notice that you can do here is you cancel out these two terms. You have a negative square root of 5 and a positive square root of 5, and those add to equal 0, or they cancel out with each other. And then you could take the square root of 25 by reducing it, which gives you 1 minus 5. And you no longer have a radical in the denominator. Now you could continue with the top. 8 times 1 is 8, and 8 times negative square root of 5 is 8, negative 8 square root of 5. And then you keep reducing that way, but this action right here, multiplying by the conjugate, eliminates the radical denominator because you create a perfect square at the end, and then you cancel out those two in the middle. That should happen every single time when you're multiplying by the conjugate. It's a lot of work, but with a lot of practice, it should come second nature and very, very easy to you. All right, so that is all. Thank you very much.